Hello everyone, I would like to thank and welcome you all to the Cudia City Wash Drainage Concept Report virtual public meeting. To start off, let me introduce myself. My name is Lana Nabati and I'm the Flood Control District of Maricopa County Project Manager. Also, we have with us Rob Lyons from the consultant team, and he is the consultant project manager. Before we begin, please note that the virtual public presentation and comment period are now available from April 26th to May 7th. On this slide, we have the meeting agenda. During this virtual meeting, I will be talking about the Flood Control District of Maricopa County's goals and missions and how that is achieved. I will be giving you some feedback for the Cudia City Wash study and the design concept report as well. In my presentation, I will go over the project's goals and objectives. Also, I will cover what has been completed to date and the project's next steps. Rob will be talking in more detail about the floodplain effort and the design concept report for Cudia City Wash and mitigation alternatives. What is the Flood Control District of Maricopa County? Even though Maricopa County is in a desert, flood occurs during two distinct rainy seasons, the summer monsoon and the frontal winter rains. Although the Flood Control District has made significant progress over the years, work remains to be done. Maricopa County continues to be one of the fastest growing counties in the United States, with over 200 people moving here every day. What are the district goals? Our primary goal is to reduce flood risk for existing and future residents in the community and the county. So how do we do this? The district studies watershed throughout Maricopa County to identify the location and intensity of flood hazards and risk. This done by evaluating the existing flood hazards, floodplain, and risks, and through conducting public outreach to inform the residents and the community leaders about the type of flood hazards and risks that can occur from moderate to large storms. Then we develop alternatives and solutions to mitigate the flood hazards and reduce flood risk. Here are some of the project's background and goals. One of the studies that the district has been completed is the Cudia City Wash Area Drainage Master Study, and it's a regional drainage study that was conducted by the Flood Control District of Maricopa County in partnership with the City of Phoenix and the Town of Paradise Valley. This study was completed in March 2020, and you can find all the project's data and reports on the district website. The Cudia City Wash Area Drainage Master Study is a restudy of the ACDC Area Drainage Master Study Phase 1, which was done in early 90s. It covered the watershed area between the Cudia City Wash and 10th Street Wash. The study area is approximately 14 square miles, and as you see on the map, it is located within a small portion of unincorporated Maricopa County area, the Town of Paradise Valley, and the City of Phoenix. Why are we doing this study? The district decided to prioritize this study for the following reasons. This watershed has not been studied since 1994. New development has occurred within this watershed. Also, new technologies are available to create more accurate mapping, hydrology, and hydraulic analysis. Since the summer of 2014, homes and infrastructures in the study area have experienced increased flooding. Awareness of flood hazards and risks can help residents reduce risk of injury, death, and property damage. The following are the study goals and objectives. As I mentioned earlier, the study was completed in 2020 and was done as part of Phase 1. Currently, we are working on the Phase 2 and preparing design concept report for Cudia City Wash Echo Canyon Zone 4. This wash was identified as a potential significant flood hazard area in the study phase. As you see on the map, this is the location for Zone 4 project. and it is within the city of Phoenix and the town of Paradise Valley jurisdictions. The project goals are revising FEMA-designated flood zones as necessary to better define the flood risks, identifying potential solutions and costs to reduce flood risk by working with the City of Phoenix, the Town of Paradise Valley, HOAs, and residents. Based on the fund availability, we will determine when and how to proceed with the mitigation plan. As part of the Phase 2 study, we will also be conducting public outreach to seek public input for the developed mitigation alternatives. I will go over what has been completed to date and the project's next steps. We have created a comprehensive database of critical information, including known flooding and drainage areas from the City of Phoenix, the Town of Paradise Valley, stakeholder interviews, and comments received at the May 2019 public meeting. As you see on this slide, at least 123 drainage complaints have been logged within the area drainage master study boundary. We identified potential flood hazard area through the development of detailed hydraulic models using updated technologies. With the completion of the modeling and flood hazards identification effort, study results shows potential significant flood hazards in 6 zones. We developed high-level recommended solutions to mitigate flood hazards for the identified flood-prone areas. And we evaluated FEMA floodplains within this watershed for potential to redelineate the existing one. The next steps are to seek public input of the potential mitigation alternatives that were developed and are presented at this public meeting. Comments and recommendations from the public will be evaluated by the project team. We want to develop 15% plans associated with cost estimate and reports to mitigate the flood hazards and reduce the flood risk. Another public meeting will be conducted to review the draft FEMA floodplain redelineation and to share the recommended alternatives. Further technical analysis of the proposed alternatives will be required at the design stage. And with that, I will hand the floor to our consultant, Rob Lyons from J.E. Fuller Engineering firm. Thanks.
Hello, my name is Rob Lyons. I'm a civil engineer who works for J.E. Fuller Hydrology and Geomorphology, and we're currently under contract with the Flood Control District of Maricopa County to do the technical analysis for this drainage concept report. A detailed flood model was developed during the Cudia City Wash Area Drainage Master Study that Lana previously mentioned, so we were able to hit the ground running using a model that was already developed. This model can simulate many types of storms, including actual storms that have happened around the Phoenix metro area, or it can model synthetic storms like the 1% annual chance storm, which is most well known as the 100-year flood. The 100-year flood, or the 1% annual chance storm, is the storm that has a 1% chance of happening in any given year. This slide shows a zoomed in view of Cudia City Wash and the design concept report study area. You can see it goes from basically the Phoenix Country Day School on the downstream side to Tatum Boulevard on the upstream side. And also on the slide, you can see the 100-year model flow depths. The flood model that I mentioned is a two-dimensional model, specifically Flow2D, which is capable of simulating both rainfall, infiltration, and flood routing. This image is from another study that the Flood Control District performed several years back, which simulates the floodwater running off South Mountain and inundating urban areas within South Phoenix. The Flow2D model is a very detailed model that's grid-based, and this particular model uses a 15 by 15 foot grid. So for each grid, you have model input such as terrain, infiltration, rainfall, culverts, buildings, walls, etc. And then the output is just as detailed with flow rates at each grid, water depths, velocities, or the speed of flow and the direction of flow. The Flood Control District has been using this model for over 10 years and has found that the results are better than all past software applications. This is a 3D animation of the flood model, or the 100-year storm, and we're zoomed out so you can see that the runoff's coming off of Camelback Mountain, Mummy Mountain, and the Phoenix Mountains Preserve. The model creates output at every 5-minute interval, so you can use the output or the flow depth results and overlay them in Google Earth to get a picture of where the source of the runoff and the flooding is coming from, as well as how the runoff is making it through the stream system. Now we'll zoom in on different portions of Cudia City Wash. So this is the section that's in between Tatum Boulevard and McDonald. And now we're moving in between McDonald and 44th Street. And here you can see that during the beginning of the storm, the water is mostly contained within the main channel, but as the flood starts to rise, it goes out into the floodplain and the overbanks. So this section is downstream of 44th Street. And now we're moving at the downstream end of the study near the Phoenix Country Day School at Stanford Drive. A floodplain evaluation was initiated with the DCR to compare the Flow2D model results to the existing FEMA floodplain. The results indicated that the existing FEMA floodplain may overpredict the 100-year flood extents. Therefore, the district, Town of Paradise Valley, and City of Phoenix agreed that the floodplain should be revised. This should have the result of removing some properties from the floodplain and potentially eliminating the requirement for flood insurance. The draft floodplain should be complete in the fall of 2021, and the district, town, and city intend to present the results to the public before it gets formally submitted to FEMA. If all goes as planned this winter, the package could be submitted to FEMA for review and approval. Given that it's a federal government agency, it's hard to predict the number of comments they may have or revisions required and the approval process. So we're tentatively estimating the fall of 2022 for FEMA approval, and then the spring of 2023 for actually updated effective floodplains on the maps. The second part of the DCR is to evaluate potential flood mitigation projects that can reduce the flood hazard. It should be noted that the City of Phoenix, Town of Paradise Valley, and the district do not have any current funding for projects in this area. There are no dollars in the budget to do any work in this area, and it will have to be programmed in the future. However, they recognize the need to have mitigation solutions ready in the event that funding does become available. So we'd like to receive feedback from the public to help us identify solutions that do have some merit that could be potentially designed and constructed in the future. This map shows how the DCR study area has been broken up into 3 zones, with 4A on the downstream end or on the west end, 4C on the east end, and then 4B in the middle. Each mitigation alternative has and will be evaluated based on the criteria shown on this slide, starting with mitigation effectiveness. How effective is the solution at reducing the flood hazard versus construction cost, whether it's acceptable to the public, what level of utility conflicts are going to come up, along with environmental impacts, and then consideration for future maintenance of whatever the facility is. The project stakeholders have already been through a preliminary alternatives evaluation phase, and only the projects that met the criteria that I showed on the previous slide are going to be presented today. The first alternative I'd like to present actually spans all 3 zones, 4A, B, and C, and we're calling it the vegetation management and minor channel grading alternative. There are 3 locations that would benefit from some minor channel reshaping. The vegetation removal would be limited to non-native or invasive species, and then trimming large branches and debris that's down in the low flow channel that's obstructing flows. This alternative would require the cooperation of the majority of homeowners to make sure that the vegetation is maintained. The technical team has simulated the hydraulic benefits of this alternative. This slide shows the flood depth reduction assuming the project was undertaken. So for example, in the 100-year flood, flow depths could be expected to drop as much as 0.85 feet or 10 inches. That's in the darker green colors. But the majority of the wash would see a depth reduction of less than half a foot or 6 inches. So there is a noticeable benefit in maintaining the wash. The next alternative is between Stanford Drive and 40th Street within Zone 4A. This slide shows the combination of two alternatives. The first is improving the culvert under Stanford Drive. The current culvert inlet north of Stanford Drive causes flow restriction, and floodwater can overtop Stanford Drive in larger storm events. The culverts themselves would not be replaced because they actually have a lot of capacity. The second part of the alternative is channel improvements and grading in the east floodplain, which can improve the performance of the channel in the culvert inlet. This grading would be performed on the Flood Control District of Maricopa County owned land. The black line work that you see on the figure shows the boundary of the Flood Control District land. This slide shows again the reduction in the 100-year water depth. You can see up to 2 feet of depth reduction within the vicinity of the project. The overtopping flow of Stanford Drive caused by the 100-year flood would be reduced by 50%. So therefore, this overtopping of Stanford Drive would become a more rare event and would probably only occur in very large storms. The next alternative also applies to Zone 4A and would mitigate flooding on large tributaries to Cudia City Wash coming from the north. This alternative consists of the addition of underground storm drain pipes along existing roads. There are 3 storm drain options, which are shown, you can see on the legend down in the lower right hand corner of the slide. The storm drain alignments are strategically located to intercept floodwater and reduce the flood hazard downstream. So the idea here is to pick up water as far upstream as you can, or at least feasibly can, so that you get the most benefit of reducing the flood hazard downstream. As with before alternatives, this slide shows the reduction in the 100-year water depth. As expected, the depth reduction is downstream of where the storm drain inlet locations would be. So with this alternative, you can see that the flow depths are reduced by as much as 0.6 feet or 7 inches. The next alternative is within Zone 4B and has to do with the existing culvert underneath 44th Street along Cudia City Wash. The existing culvert isn't sufficient to pass the 100-year flow, or even flows not quite as large as the 100-year flood. So this alternative looks at increasing the capacity of the culvert by lowering the bottom of the culvert and effectively increasing the height of the culvert. And to do this, we have to keep in mind maintenance considerations. So to keep sediment out of the culvert, you have to basically do some channelization up and downstream, which is shown here on this profile. And it would result in the need of a drop structure on the upstream end to accommodate that lowering of the wash. This slide here shows the benefit of this alternative. You can see again 100-year water surface reductions, and these reductions result in up to 2 feet of lowering, and of course less frequent overtopping of 44th Street. I'd like to reiterate that none of these projects have or will be authorized for construction in the near future. There is currently no funding in place for any of these improvements that I've presented. The city and town have to weigh the benefit and cost of these projects with all of the other infrastructure needs of the entire community. However, your input is needed to help the city and town identify projects that are acceptable and that could be planned for if and when funding becomes available. We have developed a survey that we'd like all of the residents and property owners within the area to complete. There's a SurveyMonkey link on this slide and a link to the project website. And if you have any other questions or suggestions, please feel free to reach out to Angela Munoz or Lana Nabati. Their contact information is listed on the bottom of the screen. And I really hope you found this presentation informative, and we look forward to hearing your feedback. Thank you.